So my name's Faye, and my research is all about the segmental coordination in people with Parkinson's and who have freezing of gait. So Parkinson's disease is the second most common neurodegenerative disease, with more than half of people with Parkinson's experiencing freezing of gait. So freezing of gait is a common and debilitating symptom of Parkinson's, which is commonly triggered by turning. And it's been shown that people with freezing of gait turn with an en-bloc strategy where the head, the torso and the pelvis rotate in line in the transverse plane, which differs to typical turning strategies that people tend to use, as this tends to follow a more top-down rotation pattern where the head leads, followed then by the torso and the pelvis. However, previous research has pulled left and right turns together, which may disguise any difficulties experienced while turning towards the most affected side, as people with Parkinson's often have a unilateral onset. So this research is focused on comparing turns towards the most and the least affected side in people with freezing of gait. So we got 6 people with freezing of gait to walk to this yellow target, do a 360-degree turn one way and a 360-degree turn the other way, before then continuing to the next target and repeating the task. So for this analysis, we exclude any turns with any freezing of gait or voluntary stopping in it. So one of the limitations of the previous research is that it's focused on the amount of separation between segments and doesn't look at sort of the regulation of turning over time. So in order to add to our understanding, we use vector coding to quantify coupling angle between the segments. So this is essentially plotted by plotting the two angles against each other and then measuring the angle of this line from the right horizontal between each frame. So a 45-degree angle would be moving perfectly in line at the same speed, or known as in phase. So coupling angle was calculated for the head and the torso, the head and the pelvis, and the torso and the pelvis, and then this was split into coordination bins, where the in-phase coordination bin was split into further 5-degree sections, so we can get a bit more detail about these small changes in coordination within this 42.5 to 47.5 degree bin being the most in phase. So what we found that in the head and pelvis coupling angle, that turns towards the least affected side actually had a greater percentage of the turn in these slightly more head and slightly more pelvis dominant sections, which suggests that the head leads the pelvis to a greater extent when turning towards the least affected side. Although there was no change in maximum angular difference, so possibly looking at a more continuous analysis will provide more clarity on the strategies used and be useful to relate these results to stepping. There was also a greater percentage of the turn in the most in-phase category in the head and torso coordination when turning towards the most affected side, which suggests a bit more of an en-bloc strategy when turning towards this most affected side. And again, there was no difference in the maximum angular difference. And there were no differences at all between the most and least affected side when looking at the torso and pelvis coupling angle, which means that the torso and pelvis move pretty en bloc when turning towards each side. So just to reiterate the key points, in people with freezing of gait, the head leads both the pelvis and the torso to a greater extent when turning towards the least affected side. And the torso and pelvis move en bloc when turning towards the most and least affected side. And finally, vector coding can provide a greater insight into turning in regards to this regulation of turning over time. Thank you.